Hey students, this is lesson 6.3. In this lesson, we are going to determine whether a quadrilateral is a parallelogram. We'll be learning some different ways we can do that. Go ahead and do the review. I'll check back with you. All right, so here's what we're going to be using. There's several ways you can tell if a quadrilateral is a parallelogram. If both pairs of opposite sides are congruent. If an angle of a quadrilateral is supplementary to both consecutive angles. If both pairs of opposite angles are congruent. If the diagonals of a quadrilateral bisect each other. Or if one pair of opposite sides of a quadrilateral is both congruent and parallel, then any of those ways will show that the quadrilateral is a parallelogram. Go ahead and do 11 through 16 using those. All right, for what value of x must RSTU be a parallelogram? So what we're going to do is assume that this is a quadrilateral to begin with. Then we know that if it is a parallelogram, then RU has to be congruent to ST. So this would have to be congruent to that. And we should also have that those two would be congruent. And if that's true, then we can get some equations like 5y is equal to x plus 8, and 4y minus 3 is equal to 2y plus 5. And the second equation we can solve for y, so let's subtract 2y from both sides, add 3 to both sides, and divide both sides by 2, and we get y equals 4. And if we substitute that 4 in for x here, or for y here, we get 5 times 4 is equal to x plus 8. And so subtracting 8 from both sides, we get x is equal to 12. All right, so if this is indeed a parallelogram, opposite sides have to be congruent, and for that to happen, x would have to be 12. Go ahead and do problem 1 here. All right, to decide whether a quadrilateral is a parallelogram, we're going to use one of those theorems earlier. So can we prove that this quadrilateral is a parallelogram based on the information? What theorem can we use? So it says AE is equal to CE is equal to 14. So those are the same. And we also have that DB is equal to 2 times DE. And just thinking about this, since DB is equal to 2 times DE, and both of those, both DB and 2DE contain the segment DE, we can use subtraction to show that DE is congruent to EB. So we're going to get this. And then since those are congruent, we have that AC and BD bisect each other. And if they bisect each other, then ABCD is a parallelogram. So that's the idea here. I'm going to fill in the missing reasons for that. All right, so here's my proof. My givens up to here. And then to show that BE is congruent to ED, I'm just using the segment addition postula here to show that DB is equal to DE plus EB, and 2 times DE is also equal to DE plus EB, and that's the transitive property of equality. And so just subtracting DE from both sides, I get DE is equal to EB. And then once we know that those two are equal, and we had already have that AE is equal to EC. So we know AC and BD bisect each other by the definition of bisecting. And the last step then is ABCD is a quadrilateral, and that's because quadrilaterals, or ABCD is a parallelogram, sorry, and that's because quadrilaterals with bisecting diagonals are parallelograms. All right. I'll show you this proof also. So if we know that the measure of angle Y is equal to 49, the measure of angle Z is 131, and the measure of angle W is 49, is this a parallelogram? The way we're going to show this is just show that Y plus Z, these two, they add up to 180, because 49 plus 131 is 180, and Z plus W also add up to 180. And then we're going to use the idea that if an angle is supplementary to both its consecutive angles, then the quadrilateral is a parallelogram. So I'll fill in the reasons for that. There's one way to show that. Go ahead and do this problem 2 here. I'll check back with you. All right, problem 3. Table tray can be adjusted up or down by raising or lowering the table on its hinge like shown. Will the table always remain parallel to the surface that it sits on? Explain. It looks like opposite sides are congruent because opposite sides on one set, one pair are 5 and the other are 10. And so 10 is equal to 10 and 5 is equal to 5 by reflection property. And so now we can say the quadrilateral is a parallelogram since both pairs of opposite sides are congruent. All right, you try this one. All right, that's the end of the lesson. Go ahead and do the lesson check, and we'll talk about your answers next time we meet in class.